Bismillahirrahmanirrahim. In this video, we are going to solve a numerical problem related to the vestigial sideband. The example or the problem is taken from the BP Lati book, but this problem is useful for general understanding as well. Whoever wants to learn the vestigial sideband uh, can be benefited from this problem. The problem states that the carrier frequency of the certain vestigial sideband Fc is equal to 20 kilohertz. So we are given with the carrier frequency which is 20 kilohertz. And the baseband signal bandwidth is 6 kilohertz. So we are also given with a baseband signal bandwidth which is 6 kilohertz. The vestigial shaping filter of the input which cuts off the lower sideband gradually over 2 kilohertz is shown in figure. So the frequency response of the vestigial sideband shaping filter is given to you. The vestigial shaping filter frequency response is given to you, which is given in figure 1. And you are asked to draw that response of the output filter H naught of F. So we need to draw the response of H naught of F. Hi of F, which is the vestigial shaping filter, the response of the vestigial shaping filter is given to you. And if you can see over here, at minus 26 kilohertz, we have 0, which is like this. The second important point is minus 22 kilohertz, and the third important point is minus 18 kilohertz. The minus 20 kilohertz is in between this linear curve, so this is not that important. These 3 points are important. Similarly, for the right hand side, 18 kilohertz, 22 kilohertz, 26 kilohertz are important, because at 22 kilohertz we have 0.5, at 26 kilohertz we have 1, and 18 kilohertz we have 0. So now we need to plot the H naught of F, and we are given with the carrier frequency Fc. And now we know that H naught of F is given as 1 divided by HIF minus Fc plus HIF plus Fc. Here HIF minus Fc is basically HIF, but that is shifted to the right by equal to Fc, which is 20 kilohertz. Fine. Similarly, HIF plus Fc is the same vestigial shaping filter, but it is shifted to the left by Fc, which is 20 kilohertz. Fine. So what we need to do is that we can solve this problem in 4 steps. First, we need to find HIF plus Fc, then we need to find HIF minus Fc, and then because we have plus over here, so we are going to take the combine effect. And finally, in the 4th step, we are going to divide this by 1, and we are going to find the frequency response of the H naught of F. So let us start. The first step is to find HIF plus Fc, which is basically this HIF, but is shifted to the left by 20 kilohertz. Now if I shift this spectrum to the left by 20 kilohertz, this will become minus 46 kilohertz, this will become minus 42 kilohertz, this will become minus 38 kilohertz, and this shifted to the left by 20, this will become minus 2 kilohertz. Fine. This will this is going to be 0, but this is not the important. This is going to be 2 kilohertz, and this is going to be 6 kilohertz. Fine. Let me omit this one. Fine. These 3 are important points. So if we shift this to the left, we are going to have responses like this. HIF plus Fc is basically this function, this response shifted to the left equal to Fc, which is 20 kilohertz. So here we go. This is your HIF plus Fc, which is the same HIF, but it is shifted to the left by 20 kilohertz. If you can see over here, this was minus 26 kilohertz over here. This is now minus 46 kilohertz over here. This is minus 22. This is minus 42. This is minus 18. This is minus 38. And similarly for the right hand side, 18 minus 20 is minus 2. So we have minus 2 over here, 2 and 6 over here. So the first step is done. We have plotted HIF plus Fc. The first step is done. Now in the second step, we need to plot HIF minus Fc. And HIF minus Fc, this thing which is HIF minus Fc, is basically this frequency response, but is shifted to the right by 20 kilohertz. Why by 20 kilohertz? Because Fc is equal to 20 kilohertz. Fine. So we need to shift the spectrum by 20 kilohertz to the right. Now when minus 26 kilohertz is shifted by 20 kilohertz to the right, this will become minus 6 kilohertz. Similarly, this will become minus 2 kilohertz, this will become 2 kilohertz, this will become 38 kilohertz, this will become 42 kilohertz, this will become 46 kilohertz. Fine. So in this way, we are going to plot the HIF minus FC. And if you see over here, this is my HIF minus FC. And this is basically your H of F, but is shifted to the right by 20 kilohertz. Fine. So if we shift this signal, if we shift this signal to the right by 20 kilohertz, this response which was given in the question, to the right by 20 kilohertz, we get HIF minus FC. Now we got HIF plus FC and HIF minus FC. Now the third step is to add both two. If you can see over here, we have a plus over here. So we are going to take the combined effect of these two. The third step is to take the combined effect of these two. So now we are going to take the combined effect of both. This is HIF plus FC. This is HIF minus FC. Now we are going to take the combined effect of both. And this is your combined effect of both. This is your step number 3. We have HIF plus FC as well as HIF minus FC. So we have combined these two. As a result, we have this function over here. Now, as we know that the baseband signal is of 6 kilohertz and the output filter is of low frequency, so we are going to pass it to the output filter or equal to the baseband signal bandwidth, which is 6 kilohertz, and as a result, the higher frequency components will be ignored. As a result, this component will be ignored as well as this component will be ignored. So we are going to have HIF plus FCI plus HIF minus FC like this. Now if you see over here, from here to here we have linear curve, and from here to here we have a linear curve. Now the average from here to here, because this is 0, this is 0.25, is 0.25, this is 0 and this is 0.5. Average is 0.25. Similarly, this curve average is 0.25. And if you add both of them, you get 0.5. So what we are going to do that instead of these two linear curves, we are going to draw a flat response. So this is your flat response, which is equal to 0.5, because 0.25 plus 0.25 is 0.5. So now this is your HIF plus FC plus HIF minus FC. The third step is done. The fourth step is to take this reciprocal. Why do we take the reciprocal? Because if you see the equation over here, H naught of F is equal to 1 by this thing. We have found out this thing, this is remaining. So now we are going to take the reciprocal, and as a result, when I take the reciprocal, I have this function. Because 1 divided by 0.5 is 1, and 1 divided by 1 is 1, and 1 divided by 0.5 is 2. As a result, I am going to get the response of this function. So this is your response of the output filter H naught of F. So we have found the response of the output filter H naught of F, and that's what was required in the question. Thank you.